All right, I have only a student here. Dear students. Okay, and my name is Esther. I'm going to be your chemistry tutor. Okay, so our topic this afternoon is on atomic structure, or you can put it this way, the structure of an atom. Now, atom is everywhere around us.
Oh, sorry.
In the sense that.
Sorry, Mrs. Esther.
Okay.
At first you need to on your camera. Then secondly, is that the first topic on the curriculum?
Yeah, structure of an atom.
Okay then. So is that you share a slide or you on the camera?
Okay. All right, can you see what I'm sharing?
Yes, ma'am.
All right, so good afternoon once again, and my name is Ms. Esther. Okay, so I am your chemistry teacher, and our topic this afternoon is on atomic structure. Okay, so as I earlier mentioned, atom is everywhere around us. Okay, yeah, sorry, before I proceed, I have certain rules for my class. Now, the class is not meant for a teacher alone. This class is meant for both the teacher and also the students. So it means that in the course of my teaching, I won't be the only one to do the talking. At least I also expect my students to also contribute their own quota towards the success of the class. Is that okay?
Yes, ma'am.
All right, so I have on my screen just a brief history of an atom. Now, we can't talk about an atom without talking about matter. Now, I mentioned that atom is everywhere around us because our planet or our world is full of matter. We also are examples of matter. Now, atom is considered to be the smallest particle of a matter, meaning that in matter there is an atom. Now, from our basic understanding of what matter is, right from our primary school, you will agree with me that a matter is anything that has weight in it and also occupies space. Matter can exist in solid, in liquid, and also in gaseous form. Now, this atom is actually found in in a matter. So the whole concept of an atom was not just a day discovery. It was actually a discovery that was made by many scientists. And all thanks to them, we have something to say or to discuss about an atom. Now, as I earlier mentioned, the first scientists who actually discovered what a matter is proposed a better idea or a concept of it to be an indivisible thing. That an atom is something that is indivisible. Now, as humans, we are actually inquisitive in nature, and due to our advancement or the advanced nature of our brain, inquisitiveness is actually part of us. Now, as science continued to advance, scientists became more curious, and they kept on questioning and questioning and questioning. that if this thing is actually indivisible, something ought to be wrong somewhere. I think so. But later on, gradually, scientists such as J.J. Thompson, Rutherford, and also Niels Bohr were able to give their own understanding of an atom. And gradually, we came to realize that an atom is not, and this is not regarded as what indivisible, meaning that in an atom, there are actually what we call subatomic particles. So I'll be talking about the subatomic particles of an atom, and also the concept of atom as proposed by different scientists who are of what an atom is. Now, atoms have 3 types of subatomic particles. And these subatomic particles are protons, neutrons, and also electrons. Now, the design of an atom or the model of an atom was actually proposed by different scientists based on their own understanding of what an atom is. Now, electron, which is one of the subatomic particles, positively charged. Proton is positively charged, but neutron does not have a charge, meaning that the neutron is what is neutral. Now, the mass of an electron is 1 divided by 2,000 by mass of hydrogen atom. Now, the mass of a proton is equal to the mass of hydrogen atom. Now, I believe you are familiar with some of the basic elements in the periodic table, and hydrogen happens to be the first element in the periodic table. And you agree with me that elements in the periodic table are arranged based on what we call atomic number. And therefore, the atomic mass of hydrogen is 1, meaning that the atomic mass of proton is equivalent to that of hydrogen, meaning that the atomic mass of proton is also equal to what? To 1 approximately. Okay. Now, and it is taking about 1 unit. Now, the mass of neutron is equal to the mass of a hydrogen atom, and it is taken also as what? 1 unit. Now, let's talk about the discovery of the subatomic particles. Now, in 1900, J.J. Thompson, a scientist, discovered the presence of a negatively charged particle, which is known as electron. Now, electron, meaning that electron was actually discovered by J.J. Thompson. Now, he was a scientist who discovered what? Electron. And electron is negatively charged. Now, Joseph John Thomson, also known as J.J. Thomson, was the first to actually discover electron. And he's actually, because of that, he actually got a Nobel Award for that. Okay, in physics, a Nobel laureate award for that, for his discovery. Now, we also have another scientist, okay? Now, in 1886, E. Goldstein discovered new radiations in gas discharge and called them what? Carnot rays. Now, these rays are positively charged. Now, this later led to the discovery of the positively charged particles called protons. And then we also have, in 1932, Chadwick discovered the presence of particles having no charge in the atom. And these particles, we call them neutrons. Okay, so in a nutshell, just a summary of the 3 subatomic particles and who or the scientists involved in the discovery of these 3 subatomic particles. Now, the first one is J.J. Thomson. He discovered electrons, and electrons are negatively charged. Now, and in 1886, Eugene Goldstein also discovered the positively radiations in gas discharge, and these radiations are positively charged, and they were later called protons. And then we have James Chadwick, who also discovered neutrons. So these are actually the scientists involved in the discovery of the 3 subatomic particles. That is the electron, the proton, and also the neutrons. Are you with me? Hello? If you're with me, just let me know, okay?
I'm with you, ma.
All right, so do you have a question to ask on the subatomic particles and also scientists involved in the discovery of the subatomic particles?
No.
All right, thank you. So may I proceed?
Yes, ma.
So I would like us to look at the Thompson model of an atom. Okay. Now, according to J.J. Thompson, okay, an atom is similar to a Christmas pudding. Now, the pudding has a positive charge and the electrons have negative charge. We're like plums on the on the pudding. Now, if you looking at my screen, this actually that is actually, so according to Thompson, an atom consists of a positively charged sphere and the electrons are embedded in it, okay? And the negative and the positive charges are equal in magnitude. So the atom is, as a whole word, electrical word, neutral. So because the positive and the negative charges are equal in magnitude, the atom is said to be electrically what? Neutral. And in our modern understanding of an atom, we have what we call atoms that are what? Electrical neutrally what? Charged atoms. Or atoms that are electrically what? Neutral. Okay. So in a nutshell, Thompson's proposed that what an atom consists of a positively charged sphere and the electrons are embedded in it. So what you have in the screen was the design or the model of an atom as proposed by J.J. Thompson. Okay. Now let's proceed, please. Now the next one is Rutherford. Okay. Now Rutherford's model of an atom, okay, based on the alpha scattering experiments, okay, because if you look at the discovery of proton, it all started with a positively charged particle, radiation, okay, and alpha radiation is actually radiation that is positively charged. Okay, now Rutherford allowed a beam of fast-moving alpha particle having positive charge to fall on a thin gold foil. And these were actually his observation. Now, most of the alpha particles pass through the gold foil in a straight line, and some of the alpha particles were slightly deflected by what? By small angles. But very few of the alpha particles appear to be rebound. Okay, so there you have a diagram of most of the alpha particles that were not deflected. Okay, and then the second, you have few of the alpha particles that are slightly deflected. And then you also have the last one, few of them actually bounce off the nucleus, just the way a light will bounce off when it hits or strikes a medium. And we all know that, and when light strikes a medium, it causes what we call reflection. Okay, so reflection occurs when light bounces off a medium. So this was actually the behavior of few of the particles when they hit towards the nucleus. Alpha scattering experiment. Okay, now according to Rutherford, the first point is that most of the space inside an atom is empty because most of the alpha particles pass through the gold foil. Now the atom has a small nucleus, have third, the size of the nucleus is very small compared to the size of the atom, because very few alpha particles appear to rebound, and most of the positive charge okay, and that was why the alpha particles, actually most of the particles pass through the foil in a straight line. And then another point was that the atom has a small nucleus, and that was why some of the particles were slightly deflected by small angles. And the last point was that the size of the nucleus is small. So because of the small size compared to the size of the atom, okay, that was why some of them were actually they actually rebounded, or some of them actually bounced off the word when they hit the nucleus. Now, so based on Rutherford model of an atom, okay, now this is his own description of an atom, okay, from J.J. Thompson. Okay, so according to Rutherford's model of an atom has a positively charged nucleus as its center, and most of the mass of the atom is in the nucleus. Secondly, the size of the nucleus is very small compared to the size of the atom. She agreed that positively charged, okay, but most of the mass of the atom is concentrated in that nucleus, and the electrons revolve around the nucleus, okay, in different orbits. And the size of the nucleus is very small compared to the size of the atom itself. Now, so since it was actually something a discovery that was still in the process, there are actually some defects, okay, defects of Rutherford's model of an atom. So now, any particle in a circular orbit, like you spinning in a circular motion, okay, I believe if you're spinning and spinning and spinning and spinning, it will get to a point where you become exhausted. And when you become exhausted, what will happen? You will definitely fall to the middle. Now, any particle in a circular orbit will undergo acceleration. Okay. Now, and during the acceleration, the charged particle will radiate energy. Okay, it will give out energy. So the revolving electrons will lose energy because they are giving what energy. Now, as you're spinning and spinning and spinning, you're actually making use of energy in that motion. So the electrons will lose energy and fall into the nucleus, and the atom will be unstable. So we know that atoms are unstable. So if the electron will keep spinning and spinning and spinning and also radiating energy, it will come to a point where the electrons will lose energy and fall to the middle. And the middle is where we have the nucleus. But atoms are known to be to be stable components of a matter. So you have the electron, okay, negatively charged electron spinning, and then you also have the positively charged nucleus, okay, and you also have another model, and you also have a very small positively charged nucleus in the center, okay. So from J.J. Thompson, he proposed that that the electrons and the positively and the negatively charged particles are actually embedded together. But in this concept, the nucleus is very small, but the electrons are in a circular orbit around the nucleus. Okay. Now, so let's look at another scientist who actually proposed another model of an atom. His name is Niels Bohr. Now, Niels Bohr actually proposed this particular concept of an atom. So according to Bohr's model of an an atom has a positively charged nucleus at its center, and most of the mass of the atom is in the nucleus. Just the way, just like a Rutherford concept of it. Now, so it means that both of them agree that most of the mass of the atom is actually concentrated in the nucleus. Now, the electrons revolve around the nucleus in a special orbit called the discrete orbits. Now, these orbits are called shells or energy levels and are represented by letters such as K, L, M, N, O, down to the number of shells, okay, that you want to distribute the electrons. Or you can also number them as number 1, 2, down to the maximum number of shells that you would like to work with. So the K shell, okay, can also be represented as number 1. The L shell can also be represented as number 2. The M as number 3, N as number 4. The next alphabet should be what? O. Okay? And these shells, you don't just clump the electrons around the shells, because we believe that because the scientists agree that electrons revolve around the nucleus in an orbit. And you call that orbit a discrete orbit, or you call it a shell, or you also call it an energy level. Now, while the electrons are revolving in the discrete orbits, the electrons do not radiate energy. Okay, so and if you observe the diagram of the atom as proposed by Niels Bohr, you will notice that the nucleus is positively charged. Okay, and you have the different shells where the electrons reside. Okay, you have the shells where there is every tendency of finding an electron. So electron is not located in the nucleus. The nucleus is positively charged, but the electron is is orbiting around the nucleus. And based on Niels Bohr model of an atom, as these electrons are orbiting or revolving, they do not lose energy, or they do not radiate energy. And as you can see, they are not like in a complete circular motion like the model proposed by Rutherford. Okay. All right, so let's look at the distribution of the electrons in the shells. Okay, so as you can see from the previous slide, Rutherford actually labeled the shells or the orbitals, or the orbits where the electrons are found. He labeled them as follows: K, L, M, N. And we said the electrons revolve around an orbit. And these electrons are not clumped together in an orbital. Okay, there is actually a pattern for distribution of electron. So the distribution of electrons in the different shells were suggested by by Bohr and also Berry. And the following are the rules for filling electrons in the different shells. Okay, now first is that the maximum number of electrons in a shell is given by the formula 2n, where n is the number of shells. And the number of shells can be 1, 2, 3, or you can use the alphabet K, L, M, N, okay, up down to the highest alphabet that you like to work with. Okay, now the first shell is shell number 1, or the K shell. And going by the formula 2n squared, okay, so the n represents the number of the shell. So the first shell is K, and the number of the shell is shell number 1. Okay, so all you need to do is to replace the n with the number of that shell, and the number is number 1. Okay, so by the time you compute everything, that should give you 2 electrons. So it means that the K shell, or the first shell just after the nucleus, okay, is capable of accommodating a maximum of 2 electrons. Now, the second one is L, and the number assigned to it is number 2. And by the time you substitute 2 for L, you realize that the maximum number of electrons that the L shell can accommodate is, the maximum number of electrons are what? 8 electrons. So the L shell is capable of accommodating what? 8 electrons. Now the third one is M. Okay, so M can accommodate what? 18 electrons. But there is one thing you need to understand. In as much as M and N can accommodate 18 and 32 electrons, there is also another part of the rule that goes like this, that the maximum number of electrons that can be filled in the outermost shell is what? Is 8. Meaning that you cannot fill in 18 electrons in that what? In that M shell. So in M shell, we have what we call subshells, like like smaller shells, okay, collectively they form the M shell. So there are subshells in the M shells, and as such, the 18 electrons will be distributed so as to ensure that the maximum number of electrons, okay, in the outermost shell is what? Is 8. And the electron cannot be filled in a shell unless the inner shells are what? Are filled. So you can't fill the L shell without filling the K shell. And you can't fill the M shell without filling the L shell. So you have to follow this rule when it comes to filling of what? Of electrons in a shell. Are you with me?
Yes, we can hear you.
All right. So question, please.
I don't think there's any questions. Some of the students left already.
Pardon?
I don't think there's any question. Some of the students left already.
Oh, okay. All right.
Just okay, one just came back now. Mary is back. So let's see if she
Okay.
has a question.
Okay.
And you have 10 minutes to go.
All right.
Apologies
Okay. So
that
here we
are not.
no problem. No problem. Okay. So now we have just a table list of the first 20 elements. So we have from hydrogen to chlorine. Okay. So now take a look at the tables and let's study it carefully. Okay. So we have the elements, we have their symbols, we also have the atomic number, we also have the number of protons that they possess, and also the number of neutrons, and also the number of electrons, and also the distribution of electrons. And then we have what we call the valency. So we'll talk about valency in our subsequent word meeting. So hydrogen is the first element, and the atomic number. Okay, now the atomic number happens to be the number of protons. An element in the periodic table are arranged based on the atomic numbers and based on the periodic law. Okay, and the number of protons is 1. So none is empty. So hydrogen is that element that has a proton but does not have what? A neutron. And the number of electrons is 1. So the number of protons is often also used to represent the number of what? Of electrons. Because we said protons are positively charged, electrons are negatively charged. So for a neutral atom, that is an atom without a charge, the number of protons is equal to the number of electrons. Now the next element is helium. The atomic number is 2, likewise the number of protons. Okay, but the number of neutrons is also what? 2. There is actually a way to calculate the number of neutrons. Okay, even though, because we need the atomic masses of the elements. Okay, but one thing you need to know is that the proton and the neutron will give rise to what? The atomic mass. So the atomic mass is basically the sum of protons and neutrons in the nucleus of what? Of an atom. Because from the first discussion concept of this, okay, we said 2 of these subatomic particles are found in the nucleus. 1 revolves around the nucleus. So the electron is found in the orbit or in the shell. Proton and neutrons are located in the nucleus of an atom. Okay, and it is the sum of the proton and neutron that will give the atomic mass. So for lithium, the atomic number is 3, number of protons 3, number of neutrons 4, and number of electrons 3. Okay, and so when you study that carefully, you will notice that from beryllium down to chlorine, okay, the number of atomic number is equal to what? The number of protons. And also the number of proton is also equal to the number of what? Electron. Because these atoms are what? Neutral. They do not have charge. Okay, so they only possess a charge when the atom is either losing or it is what? Gaining in most cases. Okay, though we have some that will also involve in what is sharing of their electrons. So here we have the structure of the atom of the first word, 18 elements. Okay, so hydrogen happens to have a proton but without a neutron. And as you can see, the nucleus is the dark dot in the center, and you have the single word electron revolving around in the orbit, in an orbit. Now for helium, it is what? 2 electrons revolving around the orbit. But going down to lithium, so from lithium to neon, there is one common thread about them. After the first orbit, or the first orbital, as you can see, even though they do not have equal number of electrons, the common thing about lithium down to neon is that the first shell contains what? 2 electrons, as proposed by who? By Niels Bohr, based on his 2n word, 2n squared formula for filling of what? Electrons in an orbit or in a shell. So as you can see, the first shell actually obeys that particular word rule, meaning that the first shell can accommodate a maximum of what? 2 electrons. So any incoming electron would definitely move to the next word, to the next shell. And as you can see, they are revolving peacefully, patiently, without what? Radiating what? Energy. And if you notice carefully, the second shell in neon, okay, contains 8 electrons, meaning that it has, the outermost shell has obeyed the rule of having a maximum of 8 electrons in the outermost shell. Now, from sodium down to argon, okay, the first shell contains 2 electrons, the second maximum of 8, and the incoming electron had to go toward to the third shell, meaning that from sodium down to argon, the rule was actually what? Obeyed. And that is how the atomic structures of the first element are represented. Okay. Now, so we have what we call valency. Now, valency is basically the combining capacity or the combining power of an atom of an element. Now, the electrons present in the outermost shell of an atom are called valence electrons. And looking at elements arranged in different groups, those in the same group have the same number of valence electrons, okay, but not elements in the same period. Elements in the same period have what we call the same number of shells, while those in the same group, like those in group 1, will have 1 valence electrons each in their outermost shell. Elements in group 2 will also possess 2 valence electrons in their outermost shell. Now, if an atom's outermost shell is completely filled, they are inert, or least reactive. Okay, So an atom or an element such as neon and argon and helium, as you can see, that of helium, the first shell had a maximum of what? 2 electrons. Neon, the second shell, that is the outermost shell, actually had what? 8 electrons. For argon, it was also what? 8 electrons. So these elements are said to be what? Inert, and they are also what? Least reactive in nature. Okay? So those elements that do not have a maximum of these electrons in their outermost shell would definitely be what? Reactive. And their combining capacity or valency is what? Is 0. So elements such as helium, neon, and argon, and since they belong to the same group, their valency or their combining capacity or power is equal to 0. So on the inert elements, helium atom, 2 electrons in the outermost shell. Okay, others have 8 electrons in their outermost shell. And atoms having 8 electrons in their outermost shell is said they are said to have what we call the octet what configuration. That is the state of having the maximum of 8 electrons. And these atoms are said to be what? Stable. And they are also what? Least what? Reactive, because they are inert in what? In nature. Now, if an atom's outermost shell is not completely filled, it is not what? Stable. Okay? So the outermost shell can either be completely filled if it is having a maximum of 8 electrons for the shells such as from L upwards. But if the atom has only a single shell, like just the K shell, as in the case of helium, the outermost shell has what? Maximum of 2 electrons. And we also call that the doplet what? State. And that atom is also said to be what? Stable. So if an atom's outermost shell is not completely filled,
Sorry, the
it
class
is
will
not
be ending
stable.
in a moment now.
Okay. So it